Hey guys! Welcome back to the laboratory. In this video, we are looking at the molecular formula and the empirical formula. By the end of this video, you should be able to define the terms molecular formula and empirical formula, and deduce the molecular and empirical formula of different substances. So, let's go! All substances have an empirical formula. This is the simplest whole number ratio of atoms or ions of each element in a formula. In contrast is the molecular formula, which tells us the actual number of atoms or ions of each element that is present in a compound. For example, glucose has the molecular formula C6H12O6, meaning that a molecule of glucose will contain 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. However, this molecular formula can be simplified to CH2O, which is the empirical formula of glucose. We can see the same done here for benzene and butane. Benzene, with a molecular formula of C6H6, can be simplified to the empirical formula CH, and butane, with the molecular formula C4H10, can be simplified to the empirical formula C2H5. There are 2 ways you may be asked to deduce the empirical formula of a compound, the first of which is the most straightforward. This method requires for you to deduce the empirical formula from the molecular formula. Here's an example of how you may be asked this question in an exam paper. A molecule of ethane has the formula C2H6. Give the empirical formula of ethane. We can answer this question in 2 very simple steps. Firstly, we must find the highest common factor of all the subscript numbers in the molecular formula. Remember that the empirical formula is the simplest whole number ratio of atoms, and so the highest common factor must be a whole number 2. In this example, the highest common factor of the subscript numbers 2 and 6 is 2. Our final step is to divide the subscript numbers by the highest common factor that we determined in step 1. So, 2 divided by 2 is 1, and 6 divided by 2 is 3. The empirical formula of ethane is CH3. Now, in some instances, the molecular formula and the empirical formula of a substance are the same. For example, propane has the molecular formula C3H8. There is no common factor of 3 and 8 that is higher than the number 1, and so the molecular formula cannot be simplified any further. The empirical formula of propane is also C3H8. Our second method of deducing the empirical formula is slightly more complex and requires for you to deduce the empirical formula using masses or percentages. Let's start firstly by looking at how the empirical formula can be deduced using masses. Here's an example of how this question may be posed to you in an exam paper. A compound contains 10 grams of calcium and 17.8 grams of chlorine. Deduce the empirical formula of this compound. Now, before we begin any calculation, I will always advise that you lay out your working for this style of question in columns, where the heading of each column has the chemical symbol for each of the elements in the compound that you are trying to deduce the empirical formula of. In this example, we have calcium and chlorine, and so we can place these here. The first step in this method is to calculate the number of moles of each element, which is equal to the mass of the substance divided by its relative atomic mass or relative formula mass. To calculate the moles of calcium, we must do 10 grams, which is the mass given to us in the question, divided by 40, which is the relative atomic mass of calcium, and this gives us a total of 0.25 moles. Now we must do the same for chlorine. So for this calculation, we must do 17.8, which is the mass given to us in the question, divided by 35.5, which is the relative atomic mass of chlorine. And this gives us a total of 0.5 mole. The second stage of this method requires for us to find the simplest ratio between these 2 values, and we achieve this by dividing them both by the smallest number. In this case, the smallest number is 0.25. So 0.25 divided by 0.25 is equal to 1, and 0.5 divided by 0.25 is equal to 2. We now have the subscript numbers for our empirical formula. According to our calculations, the empirical formula of our compound contains 1 calcium atom for every 2 chlorine atoms. The empirical formula of this compound is CaCl2. Here's another example of this style question, only this time the composition of each element has been given to us in percentages. A compound contains 40% of sulfur and 60% of oxygen. Deduce the empirical formula of this compound. Though we are now working with percentages, the steps for this calculation are exactly the same as they were when using masses. So, we start firstly by dividing our working into columns and placing the elements from the question in the heading of each column. Next, we calculate the number of moles. The calculation for sulfur is equal to 40 divided by 32, which gives us 1.25 mole. And the calculation for oxygen is equal to 60 divided by 16, giving us 3.75 mole. Then we divide our values by the smallest value to find the simplest ratio. The smallest value is 1.25, so 1.25 divided by 1.25 is equal to 1, and 3.75 divided by 1.25 is equal to 3. The empirical formula of this compound contains 1 sulfur atom for every 3 oxygen atoms. The empirical formula for this compound is SO3. The empirical formula of a compound can also be used to deduce its molecular formula. Here's an example of how this question may be posed to you in an exam paper. Determine the molecular formula of glucose with empirical formula CH2O and relative formula mass 180. This calculation is pretty straightforward and requires for 3 simple steps. Firstly, you must calculate the mass of the empirical formula given to you in the question. The empirical formula contains 1 carbon atom, 2 hydrogen atoms, and 1 oxygen atom. So the calculation for this step would be 1 multiplied by 12, plus 1 multiplied by 2, plus 1 multiplied by 16, giving a total of 30. For step 2, you must divide the relative formula mass of the substance, which has been provided to you in the question, by its empirical formula mass. So in this case, you will divide 180 by 30, which gives a total of 6. The final step of this method requires for you to multiply the subscript numbers of the empirical formula by the value calculated in step 2. So, 1 multiplied by 6 is 6, 2 multiplied by 6 is 12, and 1 multiplied by 6 is 6. The molecular formula of glucose is C6H12O6. Here's an example of a quick task that you can attempt to test your understanding of the calculations covered in this video. Pause the video and take your time to work through each question. Press play once you're ready to check your answers. Let's talk through the answer to question number 2. Now you should have started this question by calculating the number of moles of each element. So the number of moles of carbon would be calculated by dividing 1.44 by 12, giving you a value of 0.12 mole. And the number of moles of hydrogen would be calculated by dividing 0.3 by 1, giving you a value of 0.3 mole. Next, we divide our values by the smallest value, which in this case is 0.12. So, 0.12 divided by 0.12 is 1, and 0.3 divided by 0.12 is 2.5. Now, normally at this stage, we would use the value calculated to write the empirical formula for our substance. But we cannot have 0.5 of an atom, so we must multiply this decimal out by the smallest number that will give us a whole number. In this case, that number will be 2. Now remember, we are working out the ratio of atoms, so if we are multiplying this value by 2, then we must also multiply this value by 2 to maintain the ratio. Now we can write the empirical formula for this substance, which is C2H5. Here are the answers to the other questions. So, how did you do on this task? Let me know in the comment section below. Anyway, that's it for this video, guys. Thank you for joining me in the laboratory. Please leave a like on this video if you found it useful, and don't forget to subscribe to the channel so that you don't miss another one. See you soon!